2 and negative 20 is negative 40. Yep.
Yeah, and then I found 5 and negative 8, multiply negative 40 and add to negative 3.
Good. And then what do you do with those numbers?
I separated it into 2 parts, so I got 2x squared and then minus 5x. And then the second one is negative 8x minus 20.
It's okay if you have them flip the other way, so either way should still give you the same answer. So then what do you take out of the first set?
I pulled an x out of the first one to get 2x minus 5. And a negative 4 out of the second one and 2x minus 5.
Oh, I think that should be a plus there.
2x plus 5, yeah.
And then
2x plus 5 and x minus 4.
perfect. So that's the AC grouping method, multiplying A times C, rewriting the problem out, and then the grouping part is where you're looking at the first 2 terms versus the last 2 terms and trying to factor those. We will be using the grouping part today. So we'll be looking at trying to factor something with x cubed, and the grouping part will be how we do that factoring. The second one is a perfect square trinomial. So that means that the first and the last terms are perfect squares. What do you have, Lexi?
X plus 4.
Right, yeah, just x plus 4 squared. So yesterday we talked about the special pattern to multiply this, and now it's kind of just going back. So multiplying, factoring, they're opposites of each other. You can go back and forth with either one of those. The third one here, Mitchell, we have the difference of 2 squares. So again, they're both squares, perfect squares. So how would you factor that?
So 3x plus 1, and then you do 3x minus 1.
Good. Yesterday we called that the sum and difference when we were multiplying with that pattern. The sum and the difference, one's plus, one's minus. And then the last one here is a common factor. What do they have in common? Sarah?
We could take 4x out of it.
And then what's in parentheses?
2x plus 5.
Good, 2x plus 5. So those are the 4 ways that we factored AC grouping using those 2 different special patterns, whether it's a trinomial perfect square or the difference of perfect squares, and then just this regular old GCF. And that's really what you should be looking for every problem. Is there a GCF? Can we pull something out? So these 4 methods will be applied to the factoring that we do the rest of the week. So we're still factoring it, but these methods are going to be used in the factoring. It might not be the first thing we do, but we'll be applying all parts of the method, the different ways to factor to our problems today. So I believe there are some vocab terms at the bottom, kind of talking about a couple of different things when you're looking at the directions, just to kind of understand what they mean. First one is a prime polynomial. If something is prime, what does that mean? If a number is prime, think about prime numbers. Sarah? Right, it can't be divided anymore. It can't be broken down. Something that's prime, like the number 3 is prime because 1 times 3 are the only values that make 3. But in our sense, a prime polynomial is like something that cannot be factored any further. It can't be broken down. And there, I'm going to talk about the fancy math thing here, but the thing to remember is it can't be broken down. So a prime polynomial cannot be broken down any more than it already is. Mathematically, so here's the fancy math way, a polynomial with 2 or more terms is prime if it cannot be written as a product of polynomials of lesser powers, usually using only integer coefficients and constants. So a lot of words there. Way easier to say it can't be broken down. The only thing that they should have in common are the values of 1 and the term itself, which is what prime means. Prime means it should be the value 1 and the number itself. It also means that it can't be broken down. So the first example underneath here, just to give you an idea of what something prime looks like, we have 16x squared minus 4x plus 8. What can you do with that problem? Can it be broken down?
Yes, you can take out 4.
Yeah, so you can take a 4 out and get 4x squared minus x plus 2. So there was a GCF, we could pull out that GCF. Now if you look at the inside piece, because we still have to continue to ask ourselves, is it prime or can it be broken down? So that inside piece, Shaylin, besides knowing that or looking to see that it doesn't have anything else in common, what's another way to see if it can be broken down further? See if you can factor it. So if we take A times C, Shaylin, what do you get? 8. What multiplies to be 8? Or 1 and 8. Will they ever make a negative 1? No. So in the last chapter, if something couldn't be broken down, we would say it's not factorable. Like you would probably write it NF. Cannot be factored. This now is called prime. So if you can't factor it any further, we consider that to be a prime polynomial. So this piece right here is our prime polynomial at 4x squared minus x plus 2. It's prime because 1 is a common factor of all of its terms and nothing else. There is no other common factor besides the number 1. So prime polynomial, it doesn't just have to be a single value. It can be a whole equation. Just make sure that whole equation isn't factorable. The second word underneath is factored completely, which is kind of like it being prime. So if something's factored completely, it is written as a monomial, which is one piece, or the product of monomials and one or more factored polynomials. So again, pretty wordy. When you're actually looking at the true math definition, there are a lot of words that are involved in that. But trying to look at the example underneath. So we have this problem right now that you multiplied in your homework yesterday. Now we're going to try and factor it. So the x plus 2, and then next to it we have x squared minus 5x plus 6. So the x squared minus 5x plus 6, that's the part that we're going to try and decide, can you factor it? Because it's x squared. Something that's x can't be broken down any further. It's already as far as you can go. But anything that still has an x squared could possibly be factored. How would you try and factor that one? Anna, what do you think? How would we decide if you could factor that?
The first one by the the x squared by the 6.
Okay, and that gives us just 6. What numbers multiply to be 6?
It'd be -2, -3.
So will this one factor?
Yes.
Yeah, how does it factor them?
It'd be x squared minus 2, and then
Yes? No.
wait, what?
How are you? Say it again.
It'd be x. Wait. Yes. Wait. Okay, I need a review. Okay, yeah. It would be.
I think you were all right.
Yeah, it'd be x squared. Wait, no? Yes?
Yes.
Why does she keep pausing?
Well, because you stopped.
Okay, it'd be x squared minus 2, and 6 minus 3. What? Minus 2x.
There we go. Okay, x squared minus 2x minus 3x plus 6.
Yeah.
Put the line down the middle. We can pull out an x. We can pull out a -3. And then it factors as x minus 3 and x minus 2. So factored form means that it is broken down completely, factored completely. Essentially, factored form and prime are the same exact thing. So if it's in factored form, these parentheses can't be broken down anymore either. So factored form means it's taken all the way down. So when you look here, you shouldn't have an x squared left in the problem. Then it's factored. Questions? 2 other vocab terms at the bottom. The one is factor by grouping, which is what we just did here. So this is factor by grouping. When you factor by grouping, you're pairing 2 terms together because they have something in common. Noah?
So wait, that x plus 2, that plus 2,
Yeah, over here?
That's a prime polynomial.
This is prime. Yep.
Okay.
Each one of those pieces inside are prime. So factor by grouping is usually you're pairing two terms together. Sometimes you might be grouping 3 or 4 terms. It just depends how big the problem is. But in our case, generally, we're going to be pairing 2 terms together because they have something in common. So factor by grouping, that process, you pick 2 terms. You're looking at both of those, figuring out what they have in common, and then we pull out that piece that they have in common. The last part there, when something's in quadratic form, that's when you want to check to make sure if it can be broken down. And just a reminder, anything that has an x squared in it is a quadratic form. So when it's in quadratic form, can it be broken down or factored more? That's going to be the question that's going to be consistent for us to ask. So we're going to currently skip page 12 and go to page 13, and then we'll go back to page 12. But I want to talk about factor by grouping first because we just kind of talked about it, and that's on page 12. So if you want to take my class again next year, I'll have them flip-flopped because I think it works better to go with factor by grouping first. But none of you want to do that, so don't do that. You can have me for trigger pre-calc, not for algebra 2 again. Alright, so factor, it says to factor by grouping. We have x cubed minus 2x squared minus 9x plus 18. So 4 terms up here. So far we factored things with 3 terms. But when we factor with grouping, we usually make it into 4 terms, like the one that Anna was helping us with here. Go back quick. One more. So right here, we started with 3, but we made it 4 pieces. So with this problem, it's already set up for us in 4 pieces. It just has an x cubed, which is okay. We can still factor with x cubed. So we're going to group this together. 95% of the time, you'll group the first 2 and then the last 2. Very rarely do you have to rearrange it and group different pieces together. So most often, it's the first 2 and the last 2. So Mackenzie, if we look at the first 2, what do they have in common?
An x squared.
An x squared. So you're still taking out what they have in common. We're not doing A times C because it doesn't have 3 pieces. It's already a 4-piece problem. Mackenzie, if you take out x squared, what do you have left?
X minus 2.
Good. And then how about the next one?
They have, I think they got a negative 9, or it's a regular 9.
You're right, a negative 9.
Okay, and then be minus 2 again.
Yeah. Actually drawing on a YouTube. The number 9, what the heck is going on? Wait, what the heck? We should go check on what happened. Yeah, I should.
Oh my god!
Mrs. Page, should I go check on Jared?
I mean, if you feel like you need to.
What?
If you feel like you need
Do you
to.
think we should? Your student's been missing for like 40 minutes now.
All right, so yeah. All right, Mackenzie, I'm sorry. So we have x cubed, 2x squared, minus 9x plus 18. We had x squared, x minus 2, and then you were saying, do you take out a?
You take out a negative 9.
A negative 9.
And it'd be x minus 2 again.
Right, and then you'd have x minus 2 again. Okay, and then grouping the things together, we have an x squared and a minus 9. And then the x minus 2. So that's factor by grouping. You take what's in front of the parentheses, partner them together. You take the parentheses, group those together. Now, the question you need to ask yourself, is it factored completely? Medina, you're shaking your head. Why not?
You can factor x squared minus 9, which becomes x plus 3 and x minus 3.
Awesome. And then you still have that x minus 2. Now it's factored completely. They're prime. You can't break them down anymore. So we're going to go down to number 2 in the conclusion independent practice because it's a little different. That says x to the 4th minus 14x squared plus 45. So kind of looking at the difference. The first one we just did has 4 terms. This one has 3. It's really close to the format of ax squared plus bx plus c. It's a trinomial, so very close to being that same format. So if it looks like that, you might as well try and factor it like that. So if we try to factor this, we're going to try that AC. So if it looks like AC, try the AC method. So Mitchell, that gives us 45. What 2 numbers make 45?
Oh, man.
Oh, man.
Oh, yeah, 9 and 5.
Good. 9 and 5. If
5
it's
and 5. Yeah.
if it's negative, they should both be negative. AC grouping says then you start with your first term. Well, it's x to the 4th, so I'm going to start with x to the 4th. You write your 2 factors, negative 9, but that's going to be negative 9x squared. Yeah. And then there's a negative 5x squared, and then plus 45. So it's the same process, but my powers are changing a little bit. But it's like that trinomial AC grouping.
Why are the x's squared?
Because right here, the 14x was squared. So if I'm trying to make 14x squared, we have to keep the middle x's to have the same power as the one above it. So using factor by grouping, put our little line down the middle there. Madison, what would you take out of the first pair? And what do you have left? Good. How about the second pair? Good. Awesome. So grouping the first pieces, the front pieces, x squared minus 5, and then x squared minus 9. So ask yourself the same question. Is it factored completely, or can something be broken down further than it already is? So can anything be factored still? Maddie Gray?
X squared minus 9 times x plus 3 times x minus 3.
Right. Is 5 a perfect square? No. So that just stays as x squared minus 5. If it was a 16, a 25, then we'd break down both of them. But it's 5. It's not a perfect square. Questions on those? All right, so we are going to then go back to page 12.
Should I go?
I don't want to look like a heartless person.
You're going to find here.
Saving private
Okay, so the last little part that we're going to look at are special patterns. Yesterday we looked at, Sarah, you're just going to have to go. Just go. Yesterday we did special patterns, and those special patterns that we talked about were for multiplying. So your homework last night had something like t minus 4 cubed, and then you tried to apply it to that special pattern to factor it, or to multiply it, I'm sorry. The other way to multiply this would be to just write it 3 times, multiply 2 of them together, take that answer, multiply it by the third. So the special patterns when you're multiplying, you don't need to actually have them memorized because there's another way to multiply. However, when you're factoring, there is no other way to factor when you have a binomial or the sum of 2 cubes or the difference of 2 cubes. The only way you can factor is to use the pattern. Yes, it needs to be memorized. Now it's 2 formulas. But really, it's just 1, because I'm going to show you an easy way to kind of remember them.
I don't know if that was Jared or not. The pass said Mrs. like Keenaner on it or something like that, and the guy was like, "What the heck?" And,
Okay, well, thanks for trying.
Yeah.
Okay. All right, so I'm going to write this word up here. Not Sokotoa, but good job. Soap. It's soap. It is soap. But we could do so AP for Mr. K. Here's our call. No? Okay. All right, so the reason I have the word soap up here is to help us know the signs in the parentheses. So the word soap tells us whether it should be a plus sign, a minus sign, one or the other, because there's just 2. But the word soap helps you remember, should it be a plus or should it be a minus in the parentheses. So if you look otherwise, the pattern is the same. So we have an AB, an A times B, and then a B squared. Over here is an AB, an A squared, an A times B, and a B squared. But the signs, whether it's a plus versus a minus, is the part that changes. So the S stands for the same sign. I know. I should have recorded 4th period. I forgot. What do you think O stands for? If S is the same sign, opposite sign. And then I put the A and the P together because we can't just have S-O-A. It doesn't really make a word because it should be same, opposite, addition. But instead we say always positive so that we can make a word out of it. So your last sign should always be positive or always a plus sign. So you start with the same sign, then you have the opposite sign, and then you always have a positive sign or always a plus sign. It means the same thing. But that tells me if I should have a plus or a minus and where the plus and the minus should go in the parentheses. All right, so we're going to skip these 2 examples here, and we're going to try and do the ones underneath. So if you look underneath, it says to factor the polynomial completely. The first thing that we need to do, this is a cubed minus b cubed, is figure out just what the a and the b are. Because right now the numbers inside of there, I'm going to zoom in a little bit here. Right now the numbers inside are cubed. The numbers in the problem are cubed. So if I have z cubed, what would just the a be? 1z, right. So a 1z or just a z. Because essentially you are taking the cube root of that number instead of taking the square root. How about 125? So if 125 is a value cubed,
Where's the cube root of
math number 4.
And you put
Put the
the number in.
number in. You have to do math 4 and then place the number in. So what's the cube root of 125? 5. All right, so let's try this pattern. So it starts out with A. That's a Z. And then using SOAP, S stands for the same sign. Well, what sign did we start with? So then it has to be a minus sign. And then we have B. And then you add your parenthesis. A minus B. Then we take A squared. Well, that's Z squared. Now we need the opposite sign. Well, we had a minus, so opposite is plus. Then it says take A times B. Well, those are the 2 values you have. Just multiply them together. Z times 5 is really 5Z. Always a plus sign. So now I need my plus sign. And then the last part is B squared, which is 25. So the pattern, we have an A and a B, A squared, A times B, B squared. And then the signs just change between plus and minus. This part here, are there 2 numbers that multiply together to be 25 but add to be 5? No. That part will always be prime. So that second part, you will never need to factor any further because it's always going to be a prime factor. Always. Alright, so let's look at the one underneath, a little harder. We have 81y to the 4th plus 192y. So if it's y to the 4th, it can't be a perfect cube. But what can we do to it to try and make it be a perfect cube? Okay? So we can take out a y. Those numbers are pretty big. Can we take a number out as well? So 81 and 192.
3.
Awesome. Nice job, Mitchell. A 3. So we can take out a 3. Do you know what 81 divided by 3 is?
27.
Good. So this
Whoa,
becomes 27y. I was just a guess?
Yeah.
Oh, you should have said no. I knew that. So it's y cubed because we took out a y. It started out as y to the 4th. Now it's y cubed. And then 192 divided by 3 is 64.
Oh, I knew that one.
There was a y, but we factored out the y, so now it's gone. All right, so now what we have are perfect cubes. So we need the a and the b value. So what's the cube root of 27? 3. What's the cube root of 64? 4. So now we're going to try and follow that pattern. So it's A, B. I have it listed right up here. So A is 3y. Soap, same sign. Addition. B is 4. Then my pattern says have A squared. What's 3y squared if you square all of that? 9y squared. Opposite sign means a minus. A times B. Take those two numbers we have written down and multiply them together. That's 12y. And then always a plus sign. B squared. What's B squared? 16. And that's it. Then it's factored. So the hardest part is going to be remembering the formula. I'm not going to lie. Your homework tonight is going to be a little tricky, kind of difficult. Make sure you have that packet there. Use the notes that we did, those problems that we did to help you. Tomorrow we're going to do more factoring. Friday we're going to do more factoring. Have an awesome day.
Wait, guys.